Hi guys, Buildzoid here, and today we're going to be taking a look at the BIOS on the MSI X470 Gaming Pro Carbon. This BIOS is very, very similar to most of the other MSI motherboards, I would assume. And we're going to be doing this with a 2700X, though I will drop some anecdotes about APUs just because MSI's APU support is really bad. Actually, you know what? Let's get it out of the way right now. MSI currently doesn't have APU, GPU, core clock, GPU clock settings in the BIOS. On the older BIOSes, you could actually there was a setting for GPU frequency for the APUs, but on the newer BIOSes, they removed that setting. And the reason why they removed it is on the older BIOSes, if you actually change that frequency setting, it would cause the system to crash the moment you tried to run any 3D workload. So, because I guess MSI never figured out what was causing the crashes, so they just decided to remove the setting completely. So, on this newer BIOS I have here, it's not actually present anymore. So, yeah, that's just kind of worth getting out of the way. Anyway, with the 2700X that I have here, which is provided on loan to me by alza.co.uk, so I've screwed up that transition right there. But they did loan me a 2700X, so, huge thanks to them for providing the CPU, as that means I can spend the AHOC budget on motherboards and liquid nitrogen and interesting things rather than buying CPUs. So yeah, and they're still running a sale on a whole bunch of LN2 pots from Kingpin Cooling. So if you'd like to pick up an LN2 pot for cheap in Europe, because they're a European retailer, e-retailer, then you should go check them out. I'll leave a link down in the description below. And actually, I think they're gonna probably be stocking sometime soon the new Kingpin T-Rex LN2 pots, but those won't be on sale since they're new. But I think they're going to be stocking them. I've not had confirmation of it, but they're stocking everything else so far. So, I'd say it's a pretty safe bet to say that they're probably going to pick up the T-Rex pots as well. And those are really exciting. I should be getting a review sample of one of those. So anyway, let's get into the BIOS here. So this is the so-called easy mode. I like to call this useless mode. So let's go into useful mode, also known as advanced mode. So you get there by pressing F7. F1 brings up a general help menu like on most motherboards, though there are some motherboards where that's not implemented, but most modern motherboards will have something like this. So that's that. Let's start with the OC menu, because that's the most interesting menu. So the first option you get in the OC menu is the OC Explore mode. You should leave that on Expert, because it quite frankly doesn't make a lot of difference. So as you could see, we had one little extra menu option pop up there. In the rest of the thing, we don't actually see any difference. The other difference here is that advanced DRAM configuration. Normally, if you leave it in normal mode, everything is collapsed like this, and you have to manually open it up. And if you're in expert mode, those are already all expanded for you, so you don't have to expand them yourself, which really is just the most minor of differences possible. So we're just going to leave it in expert mode from here on, because that's you should probably be using it in expert mode anyway. Now then, CPU ratio, this changes your CPU core clock. If you leave it on auto, you have boost and all of that nice stuff. If you change it, you lose boost. And the CPU basically gets locked at whatever frequency you set there. Interestingly enough, the C-state hack that works on Gigabyte motherboards doesn't work on MSI motherboards, which is actually according to AMD spec. The fact that Gigabyte motherboards go super low idle power consumption if you just leave C-states on and then do a manual overclock is not supposed to, that's not supposed to work like that. But it does on Gigabyte motherboards, and I think Asus boards do it too. But MSI boards, you turn off your C-states and your idle voltage is just going to be ridiculous, whereas the Gigabyte boards will still undervolt and downclock for idle as long as you enable your C-states. So it's just an interesting distinction there. Here you have core performance boost, which you can disable, and then you lose boost if you're in auto overclocking mode, which is pointless. You literally lose boost. This will lock the CPU to 3.7 gigahertz. So yeah, you don't want to disable that. Down core control, not as flexible as some of the other boards out there. You have only the symmetrical options as well as stock. So yeah, you can't do things like 4 plus 0, 2 plus 0, and 1 plus 0, which I think is, I do believe the Gigabyte motherboard had those implemented and actually working. So yeah, this board is just like 1 plus 1, 2 plus 2, 3 plus 3. Next, we get some memory settings, which you have XMP, which allows you to load up your memory XMP profiles for your memory. Now, the memory kit I have here is actually, it's a special memory kit I've gotten for testing some stuff. So, but basically, since it's not like a real retail kit, it only has JEDEC profiles on it. It doesn't have XMP. So, yeah, it's not very impressive. Personally, I would say I wouldn't use the XMP option. I would go and just set all your timings manually. I mean, ultimately, the XMP profiles don't change that many settings anyway, because they can't store that much data in them. Next, you have memory frequency. So, you can set your memory ratio here. It goes all the way up to 4200, though most CPUs will probably top out around 3533, even if you're on Samsung B-die memory. If you're lucky, you might get 3600 working, but generally speaking, if you actually want something that's easy to validate for stability, you're going to be sitting between 3200 and 3533. Next, we have Memory Try It, which is a bunch of pre-configured memory profiles from MSI. And I'm going to tell you not to use these because they all suck. And why do they all suck? Well, let's try load up one of these, okay? So we've loaded up that profile, and do you notice how it only set the primaries? Like, that's not useful. It's like not even, like it didn't do anything to any of the other setting. It sets the primaries only. If we go to, I don't know, let's see, maybe for one of the really extreme memory profiles, right? They might actually have done some advanced tuning there. Nope. No, they haven't. It's just, just your primaries. So for that reason, I think this is completely pointless. The other thing is these profiles don't even tell you what memory kit you should try them on. Like this 1618, 18, 1838 profile, that would be good for like it would be worth trying for E-die, D-die, AFR, MFR. There's CFR now. CFR could run with that. I'm not sure how CFR overclocks, but it's a new IC from Hynix that just came out, and I've only recently spotted it on some kits, and it's just like, yeah, well, now that exists, so I guess I'll mention it. Micron memory kits would also be for that profile, but like this 3200 1414 1434 profile, that's literally B-die only, and it doesn't mention that. Like if you don't have a B-die memory kit, you tried to run that profile, it's not happening. So it's just like kind of pointless because it just sets your primaries and it sets your frequency. This is like, I don't know, if you have 2 brain cells, you should be able to set your frequency and your primary timings. Like, that's not rocket science as far as I'm concerned. Next, you have a memory retry count, which basically sets how many times the motherboard will try to post your memory settings. I would generally not leave it at 5 because that's kind of excessive. If you don't want to be sitting there waiting for a really long boot loop when you're messing around with memory, I would leave it around 3. The other thing is, like, if you're having serious problems with just training your memory overclock, like getting it to boot, you should probably not run that overclock for daily. If you're just benchmarking, it's fine, but if your overclock is inconsistent about even just booting up, there's a pretty good chance that it's not going to be stable or stable every time you boot it up. And you really don't want to be retesting your stability every time you have boot up issues, because that's just that's getting kind of ridiculous. So, but you do have the option here. It goes all the way to 1 retry as well. So yeah, and 5 is actually the maximum. So that's that. And we set it, and then we get the advanced DRAM configuration, which now it's all back to auto. Have all of your usual timings, as well as all of your settings: gear down mode, power down enable, bank group swap, on-die terminations. Well, actually, all of your different terminations. And yeah, so all of your memory settings are here. They're easily accessible, better than some of the other motherboards where, like, Gigabyte buried the gear down mode, like, a mile away from the rest of the memory settings, which is just like, why would you do that? It's a memory setting, is it not? Why is it not in the advanced memory settings tab? But, hey, it's still somewhere. It's just a hell of a time to find it. Now then, digital all power. Here you can play with your VRM settings. There's not that many options here, but you can do things like set your load line. You should probably be using 234. And I've experimented with something because, well, we'll get to that later. But you should be using around 234. 4 will obviously droop quite significantly. Generally, you'd want to be on 2, I think. That would be like the highest one I'd use. Mode 1 tends to be excessive. It ends up giving you voltage boost, and you really don't want that. Like, you want flat or slightly a very mild slope downwards. So you'd actually want a little bit of droop, just because LLC, like the whole purpose of voltage droop is to compensate for the physical limitations of a VRM. Like, these things literally cannot handle, like, you can't perfectly transition from load to idle or from idle to load, so there's no reason to try to do that. And basically running a small amount of, running droop compensates for that inability of the voltage regulator to do that. Because basically when you do get a load transition, the droop matches roughly with the amount of load, matches with the voltage drop caused by the load transition on its own. So the voltage regulator doesn't have to do overtime to try compensate for the sudden drop in voltage due to the increase in current draw. So anyway, if you didn't understand any of that, you should probably stick to around 2 or 3. Mode 1 will generally just make your CPU run hotter and not really give you any benefits in terms of stability. So that's that. Next, you have over voltage protection. I'm not sure what exactly it does. I've not experimented with it much, but I would leave that maxed out most of the time, to be completely honest. Then you have under voltage protection, which I would also leave maxed out. And because, you know, basically these protections will just shut down the VRM if you configure your settings wrong. I don't think they would actually save you if the VRM started to malfunction, because whatever circuit is actually ensuring that those work would probably be the thing malfunctioning when you get a serious overvoltage situation. So yeah, I'd just leave those max out. Then you get overcurrent protection, which you have auto and enhanced. You should probably just run that enhanced. Because you really don't want the VRM, like, I don't know how it's implemented. It might throttle your CPU, or it might just shut down the VRM. Either of those is not something you really want happening, as far as I'm concerned. Next, you get switching frequency, and MSI has gone kind of overboard here. It goes all the way up to 1 megahertz switching frequency. Now, thing to keep in mind with this setting right here, if you go from 300 kilohertz to 600 kilohertz, your switching loss is basically double. If you go from 300 to 1000 kilohertz, they basically triple. So the amount of heat your VRM will produce will increase significantly as you crank up your switching frequency. Now, why would you want to crank up the switching frequency? Well, more switching frequency means that you have less output ripple, and the VRM is faster to respond for load transitions like idle to full load or load to idle. You know, where you have big current jumps. The VRM can respond faster to that if it's running at a higher switching frequency. The downside being the VRM runs a hell of a lot less efficient. So generally, you know, like obviously I'll test when I do my VRM thermal testing, I'll test probably like 300 kilohertz, 550, and 1000 for how it impacts VRM thermals. But for general use, you'd probably want to stay around 300 or 400 kilohertz. But we'll see. If it turns out that the VRM's cooling is sufficient, then, you know, why the hell not run 1000 kilohertz? Though your efficiency really will go down the drain when you do that. Then you have CPU VRM over temperature protection. I would generally recommend that if you don't want your... basically... MOSFETs are fine up to 125 degrees, which is why this temperature protection menu ends at 125. That's really around the highest temperature you would want to let MOSFETs get to. The thing is, everything around them, inductors don't care about being at 125, the heatsink doesn't care, the thermal pads don't care, but there's other components around the MOSFETs that do care about being at extremely high temperatures. And for the sake of the lifespan of those, I would generally recommend that for like daily settings, you should set your VRM over temperature protection to like 110 or 115 degrees, like somewhere in that range. Now, if you're just stress testing for like an hour or two, there's no reason, like you would want to probably just set it to 125 just to make sure that the VRM doesn't start throttling the CPU, completely invalidating your stress test. But if once you're done with stress testing, you would actually want the temperature limit to be set to something that actually cuts you off when you're at risk of harming your hardware if it runs in that scenario for an extended period of time. Like say your cooling system fails for some reason and so your VRM starts roasting, you'd actually want to set the temperature lower just so that it actually trips it so that you don't end up spending like several hours or days at a really, really high operating temperature. So yeah, that's neat that that's there. Next, you get Northbridge Loadland Calibration. So that's for the SoC portion of the CPU. Same situation as the CPU load line, which 2, 3 is probably where you want to run it. Mode 1 gives you a little bit of voltage boost. Then you get Northbridge overcurrent protection, which again, you should just run enhanced. Northbridge switching frequency. I don't see a reason why you'd want to crank this to 1000 kilohertz. Okay, the Northbridge doesn't really pull a ton of power. Admittedly, well, Northbridge SoC, like just MSI calling it the Northbridge does not make it the Northbridge. It's called the system on a chip. But that includes like the memory controller and all of your USB. And if you're on a APU, that also includes your iGPU. But that part of the CPU generally doesn't pull a whole lot of power. And it doesn't it's not as voltage sensitive as, say, the CPU. Like, cranking up the switching frequency there will probably not give you any worthwhile benefits in terms of, overclocking, but it'll definitely drive up your power consumption. So I would just run that at 400 kilohertz. Yeah, also, I do believe that at stock, this VRM runs with spread spectrum. Now, I've not actually checked that, but basically, if you change your switching frequency, it puts it static instead of having this spread spectrum running. And then finally, you get the VR 12 volts in overcurrent protection expander, which is actually really odd because most motherboards don't have a input power limit. That's kind of unique to MSI as far as I'm aware, that they actually worry about how much power you try to push through the 8-pin, because there's a lot of other motherboard vendors who are just like, well, if you push 500 watts through one 8-pin and it melts, no, well, not our problem. You know, you shouldn't have done that. You should have realized that you're doing something really stupid. But you do have that protection here. And again, I would leave that on overcurrent protection expander. Basically, the setting says that it says on the side, the BIOS has a freaking useful help menu for once. So yeah, basically, if you want to disable any kind of power limitations, you'd also put that on enabled. Anyway, let's keep moving down. Now, CPU core voltage. This is great. So the problem here with this motherboard is there is no offset voltage settings whatsoever. Everything is static, which has massive negative has a very negative impact on your, on your ability to fine-tune precision boost overdrive, which does work. It's just you can't do anything. Like, the problem is precision boost overdrive is dumb as hell, okay? Like, it does some cool things, but as far as its voltage controls go, it is way too voltage heavy. Like, it puts way too much voltage for any given frequency, especially once you have the scaler really, really cranked up. And if you don't crank up the scaler, the CPU doesn't like boosting very high. So you need the high scaler for a high CPU frequency, but that'll give you a very high voltage, which will then lead to thermal throttling, which will then lower your frequency, and there's no offset voltage here to compensate for the ridiculously high voltages that the scaler will apply. So that, I find, is a major issue with this motherboard because, well, you can't really like dial in the precision boost overdrive. I tried using LLC to like force more droop onto the voltage and like have it just basically, because if the idea was that basically if I set the LLC really, really high, when the CPU requests 1.5 volts on a single core workload, it won't get it because there will be a ton of V droop on that. That did not happen. In fact, it seems that unless you actually set your voltages manually, all of the digital all power settings don't seem to even maybe apply. The load line certainly doesn't, like, PBO seems to override load line settings. So, yeah, that's really unfortunate. The lack of offset voltage is really annoying. And the funny thing is, the voltage controller on this motherboard very explicitly supports offset voltage. Like, that's the highlighted feature for what this chip. So it's just a matter of MSI putting out a BIOS update and adding offset voltage if they wanted to. Because, like, the chip they're using supports it. There's no reason why they couldn't do offset voltage. They've just decided not to bother. Now then, the full voltage range goes from, let's see, if we put 1, okay, well, that's 0.1. Okay, so it goes from 0.9 volts all the way up to 1.7 volts. That is an inadequate voltage range for LN2 overclocking, but really this motherboard's not meant for that, so that's fine. Plenty of voltage to destroy your CPU if you're on ambient cooling right there. Next, you have the SoC voltage, which you have a range from, let's see if 0.5 works. No, also 0.9. Which is kind of unfortunate, because as you can clearly see, the SoC actually defaults to a voltage lower than that at stock. Maximum voltage is 1.3 volts, which is actually a bit low. Just as far as the voltage range goes. It's actually safe. Much safer than some of the other motherboards, which will let you absolutely nuke the SoC if you feel like it. But it's just, like, I don't like the restriction. You know, it's just like, well, why not have more voltage range? Though I guess it is an idiot-proofing measure, because you really can't hurt the, 1.3 volts probably isn't the best thing for the SoC. Generally speaking, you'd want to keep the SoC under 1.2 volts for long-term duration, but I don't think 1.3 volts would kill it. Well, actually, I'm pretty sure 1.3 volts wouldn't kill it. But more than that could. So it makes sense that they would have restricted you to just 1.3 volts. Funny thing is, it doesn't turn up as red, which I really think it should, because on the CPUs at least, more than 1.2 volts SoC generally doesn't do a damn thing for memory overclocking, so there's really no point to go this high, and it just generates more heat. Now let's put that right back to auto, and CLDO VDDP voltage. So this is the internal, so this is a internal voltage regulator built into the CPU itself, and this powers a subsection of the memory controller, and this thing sweet spots very, very hard. So there's a very specific voltage that your CPU will like for a certain set of frequencies and timings. Very fiddly. I'd probably just leave it on auto most of the time. You shouldn't exceed I want to say 0.95 volts or 1 volt on it. Something in that range. Can't remember right now. That is limited to 1.4 volts, which that is not exactly, something I'm particularly pleased with right there. Actually, let's see. Yeah, it's limited to 1.4 volts. I'm just checking if it isn't tied to your VCore voltage, because it is an internal voltage regulator, so it has to step down one of the input voltages for the CPU, which is either VCore or SoC. Though there are some PLL, high voltage PLLs as well. Those could feed it. Oh well. Either way, that voltage, you're probably going to end up at around 0.95 volts or 0.8 even. So you're going to end up in that kind of voltage range when overclocking. Though leaving it on auto generally works just fine. I've found that the MSI motherboards are actually very good at pushing high memory frequencies, surprisingly so. So yeah, unfortunately they also suck at APU overclocking, so it's just why? Next you get your DRAM voltage. The limit there is 2 volts. It doesn't go higher than that, which is kind of unfortunate. Some B-die memory kits will scale all the way to 2.1. E-die will scale to 2.1, but for daily usage, you should stay under 1.5 volts, pretty much regardless of what memory IC you have. There's quite a few ICs which will actually not be stable if you feed them much more than 1.35 volts. So, not really a huge loss for the daily user, just kind of annoying for someone like me. DRAM voltage, then you get DRAM VPP voltage. This voltage is useless, but you have a full range on it regardless. It goes from 1.24 to 3 volts. Stock is 2.5. This voltage does nothing for overclocking whatsoever. There. So you can leave that on auto as well. And then you get your VREF, which a lot of other motherboards would call this VTT-DDR. This is the same voltage. And it's actually like MSI is not making up terminology here. The VTT and the VREF voltage are like, I don't remember the specifics right now, but they're very closely linked together. I think VTT, like, they might be generated by the same voltage regulator, and there's just a slight difference in where they go, and they have to be equal all the time anyway. But either way, on, other motherboards, this is called VTT DDR. On this motherboard, it's called VREF. It is half your DRAM voltage. Some memory kits will prefer it to be a bit lower than half. Some memory kits will prefer it to be slightly higher than half. So, if you're at like 1.5 volts DRAM, so like 1.5, you might want to run like 0.7 there. Or if you have a kit that prefers higher, you'd run like 0.8. Though default would be 0.75. And you have to set that for both of your memory channels independently, which is kind of neat because generally, if you buy like one kit of memory, they're all going to be pretty closely matched on, like, each stick is going to like roughly the same VREF voltage. But if you bought like two different memory kits of two sticks to run like 32 gigs or something, you might find that there's like a 20 or 30 millivolt difference between the two kits in terms of what VREF voltage they prefer. In which case, it's nice that you can set it independently for each channel. So if you put the two sticks that prefer more voltage on one channel and the other two sticks on the other channel, then, you can balance it out more. Obviously, that is like excessive amounts of fiddling, but if you want to go that far, you can. Who am I to judge? I pour liquid nitrogen on CPUs. Next, you get memory change detect. So if you ever change your memory, power down the system, change your memory kit, the motherboard will actually tell you that you've changed the memory kit. You can disable that, and if you disable it, it'll ignore the fact that there's been a memory change, and it'll try to boot on the settings from your previous memory kit, which if you're going through like lots of different memory sticks, like of the same IC, and you're like binning or something, then having it disabled kind of handy. If you're actually changing from one, if you're going from like B die to AFR and you have B die settings loaded into the BIOS, having that enabled will save you a couple of reboots, because the system will not post if you try to boot B die settings on an AFR kit. So for most users, it's probably best to just leave that enabled. And you get the CPU specifications menu, which just gives you a bunch of information about your CPU, which, in my opinion, is not particularly useful, because at this point you paid for the CPU already. So, kind of too late to check what features it has. Then you have Memory Z, which lets you check your SPD profiles, which is kind of handy. Which you can see the XMP profiles there. So, yeah, that's that. Next, you get CPU features, which you have simultaneous multi-threading, global C states, which, as I said before, having your global C states enabled will not give you low idle power consumption like it does on Gigabyte motherboards. Like on Gigabyte motherboards, you can do a like all-core overclock, and as long as you have C states enabled, you're good. Like, you're going to pull very little idle power. On this motherboard, that doesn't happen. The C states get disabled whenever you start changing the CPU ratio. So, yeah, that kind of sucks. Then you get op cache control, IOMMU, spread spectrum. You can enable that. That might be for the VRM, or it might be for the BCLK. I think it's for the BCLK, which this is done basically for EMI compliance. If you're overclocking, you definitely want to disable that. Then you get relaxed EDC EDC throttling, so that translates to relaxed electrical design current throttling. Basically, your motherboard has a specification for how much current it will allow the CPU to pull, and if you disable that, it'll kind of start to ignore that specification a bit more. So it'll basically allow the CPU to pull more power, which in theory should translate into more boost. So yeah, that's handy. Honestly, if you have an MSI motherboard, I'd say you definitely actually want to enable the relaxed EDC throttling if you're messing around with PBO and stuff. Then you have AMD Cool and Quiet. This, if you disable Cool and Quiet, your power state management is going to be really, really dumb. Like, it's still going to work. It's just going to be really stupid because it's not going to use the intermediate states. It's going to go basically like,
If you have it disabled and you move the mouse, it's going to go to the single core full speed. So it's going to go to like 4.35 gigahertz because you move the mouse, and cool and quiet is disabled. Now, if you leave cool and quiet enabled, instead of going all the way to 4.3 gigahertz, it'll go to like 3 point something, which is much more reasonable. So if you are like power consumption conscious, you might want to leave that enabled. If you're having weird performance issues, you might want to just disable that. Anyway, if you leave that enabled, you get P state adjustment, which allows you to limit your maximum P state, which I have no idea why you'd want to do, because it just makes the CPU slower for no good reason. So that's a nice, useful setting right there. Then we get SVM mode, which is for virtual machines, BIOS PSP support, which I don't honestly know what that does. Let's see what the help says. I still don't know what that does. Then you get power supply idle control. If you have an old power supply, which doesn't do well with very low output power, you're going to want to put it into typical current idle. If you have a modern PSU, you want to use low current idle. It pretty significantly changes how much power you draw at idle. At least on the CPU power connector, you're going to see a difference of, say, 10 watts on the typical current idle to 5 watts on low current idle. So, well, I mean, that's 5 watts. So it's kind of marginal, but, you know, if you look at it like 5 watts versus 10 watts, that's a doubling. But if you consider that the CPU will pull like 150 to 250 watts under load, depending on what settings you're running, marginal. So, yeah, then again, it depends how much time you spend at idle versus how much time you spend at load, but, you know, so low current, like, you don't need to worry about it too much there. And then you get your Precision Boost Overdrive. They've implemented it. It works. I've tested it. Just because there's no offset voltage and there's no BCLK on this motherboard, it's really not that impressive. MSI is kind enough to actually translate your limits into watts instead of doing the gigabyte thing where they're literally just a raw 16-bit input. So unlike the gigabyte motherboard, the maximum value is like 65,535. Here it's 1,000 watts. So that's nice. It's translated into actual values. Wait, where does that start? At 100? Ooh, so I guess the thermal design current limit for this motherboard is 125 watts in that case. And 175. Oh, wait, no. That has to be because I actually enabled it. Oh, whatever. But you can max out at 1,000 amps for everything. My recommended settings are that you just max all of these out, because you don't want the CPU throttling, because the Precision Boost Overdrive scaler is dumb enough already. It's like you really don't need to throw sticks in its way. You know, it can barely walk down a straight path. You really don't want to be putting things in its way. Then you get the scaler. It goes from 2 to 10. At 10, you get stupid voltages. At 2, you don't get a lot of boost. So you're kind of stuck between you know, like, this is the problem. It's like on other motherboards, I'd completely go for the 10x scaler and then just set a very large negative voltage offset. But this motherboard doesn't have negative voltage. It doesn't have offset voltage at all. So, yeah, Precision Boost Overdrive on this motherboard is a lot less effective than on other motherboards, because Precision Boost Overdrive, left to its own devices, is dumb as a brick. So you're kind of stuck with like if you go above basically the 5x scaler, your voltages just go completely insane. And the side effect of that is that your CPU runs really, really hot, which causes a ton of thermal throttling, and you don't get a lot of boost. So your return on power consumption gets really, really bad past sort of the 5x point, which kind of sucks. But, you know, it is what it is. Motherboard doesn't have offset voltage, so you're kind of screwed in that department. Then you get VDD SOC current optimization. And I tested these because I was having issues with the Precision Boost Overdrive stuff not behaving the way I was expecting it to. And basically you can set current limits for the CPU, VDD, and SoC. I'm not sure what they apply to, but I'd leave them maxed out just because I'd just leave them maxed out. Like, I messed around with leaving them on auto, and I think I actually had problems with PBO not kicking in properly at all. So, yeah. Not sure what those do, but they're there. Well, not sure what 100% what they do, but they are there. Because I don't know what they do, because you have all these other current limits. So it's just like, why is this here? Why do we need more limits? But yeah, those are there. And then you get mode 0, which is a setting that, like,
every motherboard has it, but for the life of me, none of them have yet told me what it actually does. So that's great. So let's put everything back to auto. And move on to the rest of the BIOS, because that is the end of the OC menu. I know. It's really not that long. It's almost fully featured if it just had the freaking offset voltage, you know? It's just... yeah, so that kind of sucks. Next, let's go to the settings. You get system status, which tells you a bunch of information about the system. You can also set the date and time. You get some DMI information, which, yeah. I'm pretty sure the DMI link is an Intel-specific feature. I'm pretty sure MSI doesn't care about proper terminology. But anyway, yeah, so you have a bunch of information here. And next you have advanced settings, where you have PCIe subsystem, which you have some settings for, I think lane splitting is what somebody mentioned in the comments on the last BIOS video, is what the 4G does. But it is for more, yeah, basically allows you to run a lot more PCIe cards. Then you have slot lane configuration. So if you're running like an M.2 expansion card with like 4 M.2 SSD slots on it, then you can run 4x, 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 4x. Did I say 4x enough times? I think I did. Anyway, so you can run that. That's there. And otherwise, if you're just running a GPU, you're going to want to run it at 16x. Next, you get ACPI settings, so power LED, blinking, dual color. That's for the front, like that's for one of the case LEDs, but I can't remember, like, I don't build in cases often enough to know. Integrated peripherals, you get a whole bunch of LAN configuration stuff, SATA and HD audio. Next, you get integrated graphics configuration, not Intel graphics configuration. Which we can see nothing in because there's no APU installed. Next, you get USB configuration. Normally, you'd have like memory quantity settings and priority, like which GPU output to use, priority settings, like that kind of thing. Next, we have USB configuration stuff, XHCI and off, legacy USB support, power management setup, you know, which is mostly for what to do when the system powers on and off. And then we have Windows OS configuration, which is well, actually no, it expands into a lot of options that I don't understand, or well, yeah, I don't know what any of these do. If you go custom, then it's like an endless pit of settings, and it just keeps going on forever and ever. So yeah, I don't do a lot of stuff related to like operating system security, so I have no idea what any of that does, unfortunately. But it's there, and there's a lot of it. I guess that's a good thing. Wake up event settings, so, you know, how do you want the computer to wake up? Secure erase, you can nuke your SSD from the BIOS, which is kind of handy if you're setting up a fresh system, you know, and, you know, you can securely erase the SSD. Or if you just want to nuke your SSD for any other reason, you can do it from the BIOS instead of needing Windows or some, you know, other operating system, or like a bootable Linux USB stick or something like that. You can just do it from the BIOS, which is kind of nice to have. Next, we have boot settings, where you can configure your boot order, auto clear CMOS, post beeps, info. What's that? Whatever that is. Boot up numlock state, full screen logo display. This video is getting way too damn long. There's a lot of settings in this BIOS. Next, we have security settings. You can set a password. You can configure trusted computing. Hopefully this doesn't have more menus. No, it doesn't. Good. But I still don't know what any of these do. But you can see that the settings are here. So yeah. Next, you have chassis intrusion, and I've been talking too long for there. I started losing my voice there, but I'm fine. It's fine. This happens every so often. Need to clear my throat. And then we get save and exit setting options, which are discard changes and exit, save changes and reboot, save changes, discard changes, restore defaults, and boot override. So if you want to boot direct, like if I chose the SSD right there right now, it would just get the motherboard to boot into Windows. This is actually kind of handy. Like, I like it when motherboards have this in the BIOS, because Sometimes you might want to catch the system booting up and go into the BIOS just to check that your settings applied. And then you want to go straight from the BIOS directly into the operating system without, going through the boot process. Which some motherboards don't have that implemented, like Gigabyte. I think Gigabyte has it working, but ASRock motherboards can't seem to remember actually having it working ever. So I think it doesn't work on those. Like if you try to do a boot override, the motherboard shuts down and then boots up again anyway. So it's just like, well, it's not boot override. That's just a regular reset. Stupid motherboard. But yeah, you can just boot directly into whatever device you want to from the BIOS, which is kind of cool. And that covers the settings menu. OC profiles. You can't save that many profiles on this motherboard. It only goes up to 6, which is one of the lower counts. I think it's on par with ASRock in that department. Personally, I think more profiles, more better. And so far, I think the leader for most BIOS profiles is the X299 Dark from EVGA, which stores up to like 14. Which is kind of ridiculous. Like that's a lot of freaking profiles. But of course, if what the motherboard allows you to store is not enough, you can save them to your USB stick, and you can load them from a USB stick. So that's nice. Unfortunately, I don't have a USB stick installed, so I can't show you how that works right now. And if you choose a profile, you can set the name here, save the profile, load the profile, clear the profile. So yeah. Plenty of options to go around, and all well and good in that department. Next, we get the hardware monitor, which is where you can set your fan settings. I am not a fan of this menu, and the reason why I'm not a fan of this fan menu is because it doesn't let me change the fan speed using the keyboard. This is the BIOS. I should not be required to use the mouse, but I will give MSI credit where credit is due. Even though they force me to use the mouse, which I absolutely despise in the BIOS should be navigatable and entirely functional with just the keyboard, they have the best mouse implementation I've ever seen. Like most other motherboards, you try to use the mouse in the BIOS, and it's just laggy, janky, slow, and useless, and it like tracks weird, and it's just terrible, right? Here, it actually tracks pretty well. It's smooth. It's usable, which is like really surprising because most of the time this is like the last thing I want to be doing in the BIOS is using the mouse, and here it's actually kind of acceptable. So yeah, it's kind of nice. You can choose. Oh yeah, so you can choose which temperature sensor your fan speed is tied to. So I just set it to PCH. If we set it back to CPU, you can see that the RPM just drops. I mean, PWM or RPM. This graph is confusing. But anyway, something drops because the CPU temperature is currently lower than the chipset temperature. So yeah, and if we go to MOS, then it ramps up really hard because the MOSFETs are the warmest, of course. So yeah, that's how that works there. So you can select your temperature sensors. There's not that many temperature sensors here. You can also choose between DC voltage control, PWM voltage control, or you can leave it on auto. And you can control, I think, every single fan header on the motherboard, and there is only 6 of them in total. And I'm just going to max the pump out. There. Okay, that's not that bad. That didn't take that long to do. There's also, of course, all full speed button right here. All set default. Wait, what's cancel? Does that just stop the fans? That seems incredibly dumb. It does not stop the fans, so I don't know what that does. But anyway, so that's there. You have step up time, so you can change how quickly the fans go up and ramp up. Or, well, actually, how quickly they transition on change. So, yeah, that menu is still just janky. Like, MSI's mouse controls are better than everybody else's, but they're still mouse controls. So they still suck. And you can slow down how quickly the fan ramps down. And so, yeah, you can sort of... So if you want to, like, slow down the noise, like, RPM transitions to prevent the fans from, like... Because if you have it, like, if you set it to 0.1, seconds... then it's going to ramp up, if you have a very spiky temperature, like your temperature jumps up and down because your load is really inconsistent. So you're going from like 100% load to 0% load very, very quickly back to back. Your fans will start doing the ramp up, ramp down, ramp up, ramp down, and that'll be really, really obnoxious. So really, you would want to configure the ramp up speeds to slow that down so that they don't ramp up, ramp down, and drive you insane by, varying noise levels all the time. So yeah, that's what those settings do there. And then we get the Board Explorer, which in my opinion is the most useless part of the freaking motherboard. Like, this is literally marketing for the motherboard on the motherboard. Well, okay, now, it's not quite that bad, but it does... I mean, this is what the motherboard manual is for. Like, just saying. But there's no reason, like, it's not bad that it's there. It's just, in my opinion, completely pointless and kind of slow, and it forces you to use the mouse again, so I don't like it. Finally, we have M-Flash, which is the flash mode, and if we go into that, no, we don't want to save configuration. It actually forces the board to reboot all the way, and then it boots into BIOS flashing mode, which I don't currently have a USB stick, so, with a BIOS in there, so we can't actually flash anything. It's taking its sweet time to fire up. Oh, there it is. Yeah. And here is flash mode. So, yeah. That's the end of the BIOS for this motherboard. That's everything, I think. So, the only problem I see with this BIOS is the lack of offset voltage. Everything else, otherwise, I think MSI's BIOS is really... Also, the fan control by mouse is not cool with me, but hey, at least the mouse is well implemented, so, I can get over that. But the lack of offset voltage, that's a major problem, because PBO on its own is stupid. This motherboard has a voltage controller that supports offset voltage. There is no reason for this motherboard to not have offset voltage settings. I don't know why those aren't a thing. The memory try-it profiles are, as far as I'm concerned, a waste of time for whoever implemented them, because, because here's the thing. If they actually set some, advanced settings, I wouldn't think they're completely bloody useless, but they don't do anything more than your freaking stock timings, and you can just copy-paste those off of other memory kits, Because, a lot of these match up with real memory kits, like the 18, 20, 20, 20, 38. That's a B-die bin for at least one brand of memory. I think several memory manufacturers, maybe even. So, yeah, it's just these profiles are not particularly useful when, they just set your primaries and your frequency. Like, anyone should be able to do that on their own. This is not helpful. So, yeah. But really, my main complaint is the lack of offset vCore. That is a real problem. In the past, I wouldn't have scored against that, especially on, Intel platforms. I couldn't care less if you have offset or not. But here, with Precision Boost Overdrive, and with how stupid Overdrive tends to be about voltage levels, having offset to rein in the stupidity is really useful, and this motherboard just doesn't have it, and the end result is that for PBO, this motherboard tends to kind of underperform, because this motherboard is subject to the ridiculous voltage levels that PBO dictates when you really crank it up. So, yeah, that's a real downside. And ultimately, PBO gives you marginal performance gains most of the time. I mean, we're talking single-digit percentages most of the time. So if you're really lucky, you might see a 10% performance gain under some workloads, maybe a tad more than that. But generally speaking, it doesn't make that much difference unless you also have BCLK control, which this motherboard doesn't have at all because it doesn't have a clock gen. So I'm not scoring against that on a BIOS overview. That's just the board doesn't have a clock gen. Of course, it can't do BCLK. But yeah, the offset voltage, that's a major letdown, because otherwise, I would basically, tuning this motherboard otherwise would be a matter of set your PBO to 10x, set your wattage, set all your power and current limits to 1,000, set your VRM temperature limit to something reasonable, maybe change your VRM switching frequency, and then just crank down the core voltage with offset. Keep dropping the offset voltage until, it'll boost higher the lower you get the voltage, because the lower the voltage is, the lower your operating temperature, the more boost you get. So, that. And there's no offset voltage, so that's a major negative in my book for this motherboard. It's just no offset voltage. But anyways, this video is now extremely long. I think I made it too much of a guide when I was going through the OC menu, but yeah, that's it for the MSI BIOS. Thanks for watching. Like, share, subscribe, leave any comments, criticisms, suggestions, or questions down in the comment section below. Thanks to alza.co.uk for providing the 2700X that I used here for, well, testing out this motherboard and all that. I will drop a link down to the sale on the LN2 pots, in the comment section, maybe in the video description as well. And if you would like to support what I do here with actually hardcore overclocking, which what does supporting AHOC lead to? It allows me to buy motherboards like this one and then test them. So if you'd like to, support me, I have a Patreon, a PayPal, and there's also t-shirts you can buy. You can find a link to all of that down in the description below. That really does help out a lot. So yeah, that's it for the video. Thank you for watching, and see you all next time. Now, where did the... Right, there's the stop button.